Okay, so in this lesson, we are going to be discussing which variable to solve for. This is just part one of this section. So it says the table shows the relationship between the base length, B, and the area A of some parallelograms. All parallelograms have the same length. The base length is measured in inches and area is measured in square inches. So I want you to take a second, I want you to pause the video, and I want you to see if you can figure out what the relationship is in this table. See if you can find some sort of pattern. So pause it now, see if you can figure out. If you can't, you can just keep going. All right, but what I notice is that if I take my base and I multiply it by 3, it's going to give me the area. And in order for that to be true, I have to continue doing it, and it has to work for all of my problems, and it does. Okay, so I'm going to fill in the rest of my table. Grab my calculator, do 4.5 times 3, and I get 13.5. I have 11 divided by 2 times 3 is 16.5. All right, well, now we're going the opposite way. We have to see what we multiplied by 3 to give us 36. So I'm going to do 36 divided by 3. And I get 12. Then I'm going to do 46.5 divided by 3. And that gives me 15.5. So hopefully you would all agree that I took, for each one of these, I took the base times 3, and that equaled the area. And then when I got down here, I had to take the area and divide it by 3 to equal the base. And so it says, decide whether each equation could represent the relationship between B and A. Be prepared to explain your reasoning. Basically, it's asking which equation goes with this relationship in the table. And if we look at those, this one says the base is 3 times the area. So if I go up here and I do the area of any one of these, I will choose this one randomly, times 3, 13.5 times 3. That's going to give me 40.5. Is that what my base is? No. So that one would not be a relationship to match. Okay? So then this one says the base equals the area divided by 3. Okay, well, let's try that. I'm going to go to my area. So here's 176. I'm going to divide it by 3. And we've already done that. It's 15.5. So that one would represent the relationship. Okay? And then going on to C, it says the area is the base divided by 3. So I'm going to go up here. Let's see. Okay, here's my base. If I take it and I divide it by 3, that should equal 13.5. So 4.5 divided by 3, I get 1.5. Well, is that what this is? No. So that, oops, is not our relationship. So it's not C. All right, and then finally we have area equals 3 times the base. So again, we take the base, we multiply it by 3, and that 12 times 3 should give me 36. Let's see, 12 times 3 equals 36. So D would be true. All right, so what it's telling you here, and I think y'all would agree with me if I said both of these equations are equivalent. Okay, they're going to give us the same solution because we just proved that by using the table. Okay, so if I had a question and I asked you, all right, I know that my base, or I know that my area equals 12. So what is my base? If I were looking at these two equations and I wanted to answer this question, since I don't know what B equals, I want to use the equation that is already solved for B. That's set equal to B. Right there. Okay? And in the same thing, in the same note, if I had one where I knew that the base equaled 4 and I wanted to solve for the area, then I'm going to choose the equation that's already solved and set equal to what I'm looking for. Okay, so let's keep going and see how we're going to expand on that. So we've got a situation here, and it says, after a parade, a group of volunteers is helping to pick up trash along a 2-mile stretch of road. The group decides to divide the length of the road so that every volunteer is responsible for cleaning up equal lengths. So we've got a stretch of road here. It's 2 miles. And we're going to divide each section up into so many volunteers. Okay, so right here it says find the length of a road section for each volunteer if there are the following number of volunteers. Be prepared to explain how or show your reasoning. Okay, so we have 8 volunteers. So we're going to take that 2 miles and we're going to divide it by 8. So 2 miles divided by 8, that gives me 0.25 miles, which is 1/4 of the road. All right, next I'm going to do 2 divided by 10, and that's going to give me 0.2 miles. All right, I have 25 volunteers, so I'm going to do 2 divided by 25. That gives me 0.08 miles. And then I have 2 divided by 36, which is going to give me 0.05 miles. So number 2 says it wants us to write an equation that would make it easy to find the length of the road section in miles if there are N volunteers. So they want us to use the variable N to represent volunteers. Okay, so hopefully you started to notice a pattern here. Every single one of our equations started out with 2. So that's what I'm going to start my equation that I write with. And also every single time we divided. Okay, but each time we divided by a different number of volunteers, so that value can change. So in place of a value that can change, I'm going to use N, because that represents our volunteers. And that's going to equal the length. And I just write my L's like this. It's just a fancy little cursive L, and so you don't get it confused with the number 1. Okay, so once again, once it's asking you to find something specific, like length, okay, since that's what it's asking me to find, or making it easier to find the length, that's what I'm going to set my equation equal to what I'm trying to find. Okay, so looking at number 3, it says find the number of volunteers. So this time I'm trying to find volunteers. This time if we know the length of the road. So once again, I have this 2-mile stretch of road. And now we're dividing it up by certain specific sections of the road. Okay, we're dividing it by specific amounts. Okay, so once again, we're going to take our 2 miles and we are dividing it up by the section. Okay, so I have 2 divided by 0.4. So that is going to take 5 volunteers to clean. Okay. It's going to take 5 volunteers to clean up a section that large. Okay, so then I'm going to have 2 divided by 2/7, which will be 7 volunteers. And I'm going to have 2 divided by 0.125. Ignore that little smudge right there. Let me erase that so we don't get confused. Uh-oh. Plug my computer back up real quick. There we go. Okay, so 0.125. So that's going to be 16 volunteers. And then I have 2 divided by 6/45, which would be 15 volunteers. All right, take a second, maybe pause the video and see if you can write your own equation that once again would make it easy to find the number of volunteers in. So since we're trying to find the number of volunteers in, then that is what we want our equation set equal to, okay? And we're gonna use the variable L for miles again, okay? Pause the video, see if you can figure it out, and then play it and see if you got it right. So once again, I noticed that each time I started off this problem with a 2, okay? Because we started off having 2 miles of road. Once again, each time we took that 2 and we divided it, but the amount we divided it by changed each time, and we divided it by however many miles we were splitting it up by. So we're going to divide it by L, and that equals the number of volunteers. So once again, because that's what we were trying to find, that's what my equation needs to be set equal to. Okay. That's not the correct part of the question. Okay, 8.3. So it says a tank, or we're marking out part B, we're not doing that. So it says tank A initially contained 124 liters of water. It is then filled with more water at a constant rate of 9 liters per minute. It wants to know how many liters of water are in the tank after the following amounts of time have passed. Okay, so since it's wanting us to find how many liters of water in tank A, we're solving for liters of water. Okay, so it says 4, so let me draw you a little picture here. So we have this tank. Beautiful. Okay, and there's already 124 liters of water in it. Okay, so this is where we start. That's how much starts out in the tank. Okay, so in this problem, when the timer starts, it's starting, the water is being added on top of the water that's already in there. So for part A, it wants to know how much is in the tank after 4 minutes. So it's going to be starting to fill up, and then 4 minutes is going to pass. We have some more water in there. So we're going to calculate how much we added, but we can't forget about how much we started with. Okay? So since we started out with 124, I have to like start with that in my equation. Since there's water that's being filled up, we're going to add. And then if it's going at a rate of 9 liters per minute and 4 minutes have passed, we're going to do 9 times 4. Okay, so this right here is going to tell me how much water was filled up right there. Okay, but since it's adding on to the 124, we can't forget about that at the beginning of our equation. All right, so let's simplify that. I have the 124 stays the same, plus I have 9 times 4, which is 36. And then it wants to know how much was left in the entire tank. We're going to add those together. And we get 160 liters. All right, so now they want us to do it for any amount of minutes that could work. So the way that I started this equation was I started out with 124. Okay, and it was increasing at a rate of 9 liters per minute. But if it wants any amount of minutes, we know we're just going to multiply that by 9. And that's going to tell us the liters in the tank. They didn't really give us a variable to go with that, so We'll just say it's a capital L, or just writing out liters in the tank. Okay, there's one more. We're still dealing with that same tank, but now it wants to know how many minutes have passed M when tank A contains the following amount of water, okay? So since it wants to know how many minutes, we're trying to solve for M. Okay, so this may be easier if you take your paper and divide it up somehow. I don't know, whatever floats your boat. You don't have to do it that way. Okay, so A is, we have 151 liters, okay? So going back to my drawing of a tank. If you're a visual person, oop. I don't even know. Oh my gosh, team come out. Whatever, there's our tank. So we know we started out with the 124 liters of water. Okay, well, according to A, we now have 151 liters total. Okay, so we've got to figure out how long it took basically to go from here to here, because that's when the time started and that's what we're solving for, how many minutes. But we can't forget about, once again, that 124 we started with. Okay, so for A, we have to do 151. We have to subtract off that 124 because the time didn't start until after that was already in there. We're trying to find how long it took to get from here to there. So we have to subtract that amount off. I'll do that real quick. And that's going to give us 27. So that's my first step. So then my second step is that I have to take that 27, and again, it's filling up at a rate of 9 liters per second. So I have to, or per minute, so I have to divide that by 9. So that's going to be, it's going to take 3 minutes to fill it up at that rate. Okay, so let's do the next one. This time we have 191.5 liters. We got to subtract off that 124. And that's going to give us 67.5. Okay, so then we have to take that 67.5. It's being filled at a rate of 9 liters per minute. So I have to divide it by 9. So that's going to take 7.5 minutes. Okay, hopefully you're seeing kind of a pattern here. Let's do one more and then see if we can come up with the equation on our own. So now we start off with 270.25 liters. So my first step is going to be to take that and subtract off the 124. And so I get 146.25. Okay, so that's how much it was filled up on top of the 124. So then I have to take that amount and divide it by 9. All right, and that gives me 16.25 minutes. All right, so each time, now it wants me to do it with P amount of liters, okay? So an equation that would work for any amount of liters that could be in the tank. So each time I noticed that I started with my liters, okay? And it changed every time. So because it's changing every time, we're gonna use a variable to represent it. All right, and then every time I notice I subtracted off 124. So I'm going to take that P and I'm going to subtract off 124. And then that was, that gave me an answer each time. So we have to do this step first. So to show that we did this step first, I need to put it in parentheses so that the person solving it knows I've got to do that before I do anything else. And once we got whatever that answer was, which they'll figure out once they do the parentheses, every single time we took that answer and we divided it by 9. So we're going to take that and we're going to divide it by 9. And that's going to tell us how many minutes. So there is our equation. So once again, since it wanted to know how many minutes, it wanted us to have our equation set equal to what we were solving for. All right, so that is all for lesson 8. We're not doing number 3 and we're not doing number 4.